Hello everyone. Welcome to Physics Ki Pathshala, and we are back with a video which is not related to physics, but yes, under the miscellaneous playlist which I started around 2 weeks back because I'm very fond of calculus and geometry and trigonometry as well. So therefore, under this playlist we have this video, the third video. We started with calculating area of parallelogram, and then we get the geometric proof of derivative of a trigonometric function. So this is the third list of the playlist, which is area of a circle I'm calculating using calculus. So without any delay, let us proceed. So I've drawn something. Let me make you explain first what is this I've drawn. So we are considering a circle having a center at O and radius R, right? Now, this is the circle, as you can see, center at point O, here it is, and it has a radius R. I have marked the radius R here, right? Now, this circle is in XY plane, okay? So as you can see that on the x-axis, the intercept here is x equal to plus R, and here it is x equal to minus R. The technique we are employing here is we are considering a strip because we are calculating the area, right, of the entire circle. So we are considering a strip on the area, on its area. And how are we considering that? The strip of width dx. So this is a strip, this one, this brown colored one. I'm now shading it with red. This is the strip. And this has a width dx, correct? And it is at a distance x. Now, no matter whatever x I choose, I could have chosen it here as well, here as well, here as well. That doesn't matter. But the width of the strip remains dx. For a reason you will get to know soon, like why it is convenient to choose like this. Whereas on the strip, the vertical gap, that is dy, is this. This is dy, I have marked. So any area which is there on this strip, it is dx into dy, right? It is dx into dy. And then integrating it within appropriate limits, that is applying calculus to it, we would be able to find out the area of the circle, right? So let us start with this. Now, since we are applying this on the xy plane, so therefore, first I will employ the equation of a circle. Equation of a circle. Why equation is required? Because y is changing with x. Y is not fixed, it's a curve. So y is changing with x. So here, for a circle having a center at O, which I can call as origin as well, and radius r. So my equation is x squared plus y squared equal to r squared. It's a well-known formula for equation of a circle. From here, I can write y is equals to under root of r squared minus x squared. This we will use, right? Now notice one thing. This strip, if we say what are its y limits, the top portion, this is at x, and what is the value of y here? It is positive under root of r squared minus x squared. This is the y-intercept on the positive side of y-axis. On the negative side of y-axis, it will be the same value with a minus sign. Minus under root of r squared minus x squared. So these are the limits of dy. dy is a small element along the y direction, and its limit is minus under root of r square minus x square to plus under root of r square minus x square. And what will be the limits of x? If you think carefully, if you would have chosen this strip at this point, right here, where I have just shaded, the value of x would have been plus r, and then proceeding towards left-hand side, to cover the entire circle, the x would have gone up to minus r. So the limits of x would be plus r to minus r. So it's like this circle, one strip is here, and then adding all the strips gradually will complete the circle. So we are moving from plus r to minus r on the x-axis, and y is dependent on x. Y is dependent on x because y is continuously changing. Because if you notice that if I consider here, y is different. If I consider here, y is different. If I consider here, y is different. So y is continuously changing with x, and y depends on x as this equation, y is equal to under root of r square minus x square. So the limits of y will be in terms of x only. The limits of y will be in terms of x only. Okay, so let us start with the calculus. So this is the fundamental, like what are we doing? One should understand this. Now let us start with the calculus. Yeah. Okay. So let us consider the area of the circle to be A. So your area A, it is equal to integral dx integral dy. And as I said, y is going from minus under root of r square minus x square to positive under root of r square minus x square. And the limits of x, as I just now explained, would be plus r to minus r. Correct? Now, so we will do the integration one by one. It is a double integral because we are evaluating area. So this will come out to be integral of dy will be y only. So I write dx from plus r to minus r. This becomes y, and these are the limits. Okay. Now upper limit minus lower limit. Plus r to minus r. So we get upper limit r square minus x square minus under root of r square minus x square. Right? So this makes it twice of under root of r square minus x square. So I can write this as twice integral plus r to minus r under root of r square minus x square dx. Now, under root of r square minus x square, it is a function of x. Y is a function of x. It is basically y. So now we are doing y into dx, and this is the limits plus r to minus r. Now the standard formula for this, which we are going to use is, so here we are going to take help of, already we have started with calculus. So now we are going to take help of the formula, which is a standard formula of under root of r square minus x square dx, where r is a constant. R is a constant here, right? It is the radius of the circle. So this will be, this 2 I will write as it is, and it will be x by 2 under root of r square minus x square. And now the limits of x, it will be put, that is plus r to minus r plus r square by 2. It is all a part of the formula. R square by 2 sine inverse x by r. Sine inverse of x by r. And also limits will be put here, plus r to minus r. Let us close it. If you carefully notice in the first expression, this term, when you put minus r in the place of x, it gives you r square minus r square, that is a 0. And if you put plus r again, upper limit minus lower limit, it again gives you a 0. So upper limit minus lower limit, 0 minus 0 is 0. So the entire first term, including this x by 2 getting multiplied by the same, goes to 0. This does not contribute. It goes off to 0. Now our only job left is to evaluate the second part. Clearly, as you can see, this 2 cancels with this 2. Once the first term goes to 0, then this 2 cancels with this 2. And now, so are we left with a is equals to r square sine inverse. If you put minus r in place of x, you get sine inverse minus 1. Then minus, then you have put the upper limit, now the lower limit. Sine inverse, in place of x you put plus r, you get sine inverse 1. So this is r square. Sine inverse minus 1, this comes at a value 3 pi by 2. 3 pi by 2 is basically in degrees how much? It is 270. Pi by 2 is 90 into 3, 270. So sine inverse minus 1 is 3 pi by 2 minus sine inverse plus 1 is pi by 2. And therefore, this term, if you see, 3 pi by 2 minus pi by 2 is pi. And r square we have already obtained. So we get our very well-known formula, which we learn in junior classes. Area of a circle comes out to be pi r square. Right? So I hope you have understood this. Try doing this yourself, practice it. And look at the limits, because when you visualize the things, that how to choose a script, how to take the limits, then rest is all easy. Okay. So area of a circle is calculated using calculus method. Thank you so much. We will be coming with fun videos with mathematics, where we will be calculating surface areas and volumes of 3D figures now. So that will be a topic for next video. Thank you so much. Bye-bye. Take care. Like, share, and subscribe Physics Ki Pathshala. Bye-bye.